Hello! In this video, I'm going to show you a technique called pixel sorting, which is what I use to create images like the one behind me. There are lots of ways you can do pixel sorting. In this tutorial, I'm going to show you how to do it inside of a Google Colab Notebook. And of course, if you want to follow along, you're going to need an image to practice on. This is the image that I'm going to work on in this tutorial. Before I demonstrate how to do pixel sorting, I want to say a little bit about what pixel sorting is. Pixel sorting is a technique that was created, as far as I can tell, around 2012 by the digital artist Kim Asendorf. He used it to produce images like these. And he shared a source code. This code is written in Java. It's written for a platform called processing. What I'm going to be working with today is a port of that original code, and this port was created by the programmer Satyarth Sharma. This is written for Python, and this version expands a lot of the original functionality and adds some interesting ideas and some nice interfaces for working with it. Here is the photo of a cloud that I'm going to be working on in this tutorial. I see this as a white cloud in a blue sky, but the computer thinks of this as a grid of pixels with each pixel having a specific color. We can see that grid more clearly if I lower the resolution and zoom way in. In this case, the image is now 32 pixels wide, and you can see each pixel pretty clearly. To understand what happens when we apply pixel sorting, let's take a closer look at a single row in this image. For each pixel in this row, we can describe its color in several different ways. A hex value, an RGB value, an HSV value, a CMYK value, all of these mean the same color, which to me looks like a nice sky blue, maybe with a hint of green. Yet another way of describing this pixel's color is in terms of its HSL value, which stands for hue, saturation, and lightness. Lightness is a good one to focus on because it's pretty intuitive. The lower the lightness number, the darker it is, the higher the lightness number, the lighter it is. Here I've calculated the lightness for each pixel in this row and printed it down below. It's a bunch of numbers, it's kind of hard to make sense of. So here are those numbers plotted on a graph, where the higher they appear on the graph, the lighter that pixel is. Now let's see what happens to this row after we apply a pixel sorting algorithm. Here's the original row, and here it is after pixel sorting. As you can see, the pixels have been rearranged so that the darker pixels appear towards the left and the lighter pixels appear towards the right. They all have the same colors, but they're in a different place. In this particular run, I had the threshold set to 0.8, which means that the algorithm had a fairly high tolerance for which pixels to include in the sorting group. Here I set it to 0.6, and with a lower tolerance, it only sorted part of the image. It's easier to see which part got sorted if you compare it to the original. Here, the original is the white line, and the sorted image is the blue line. If you look closely, you'll notice that the sections now shaded in gray have been sorted and the rest has been left alone. Now let's see how the whole image looks after pixel sorting. This is the lower resolution version, and here I've sorted it with a threshold of 0.6. It's kind of hard to see what's going on, so let's take a look at this in higher resolution, and here this is the same pixel sorting algorithm and the same threshold of 0.6. It looks okay, the bottom part kind of streaked off to the right, but not much else changed. Let's bump the threshold up and see, yeah, this looks a lot different and kind of chopped up, kind of messy, but definitely there's a big difference that's been applied to this image. Let's try pixel sorting in Python. I'm working in a Colab Notebook here, so my first step is going to be installing and then importing the pixel sort module. In your case, your first step might be to make a copy of this notebook so you can follow along. I'll put a link in the description. The pixel sort module isn't automatically part of the set of modules that I can import in my Colab Notebook, so I need to install it first by using pip. And I need to prefix my pip command with the exclamation point to send this command into the environment. So I'll click the play button, let that run for a few seconds. Now that pixel sort is installed, I need to import it into this notebook to actually use it, and I'm also going to need the image module because I'm going to be working with some images. I just need to hit play, and that's all I need. Now that pixel sort is ready to go, I need to upload at least one file to work on. I'm going to do that by clicking on the file manager over here in the sidebar, and then clicking on the upload button, browsing to my file, and to take a look at this file name, I've called this cloud-smaller.jpg. First of all, you always want to avoid spaces in file names, and you also want to make sure that your file names are pretty descriptive. When you do pixel sorting and you run through this notebook, you're going to end up with lots and lots and lots of different files, and you want to make sure you can tell them apart. For pixel sort to work on this file, I need to know its location or its path, and I can get that by right-clicking on the file name and selecting Copy Path. And I need that down here in this cell that I've set up for trying it out. I'm going to close the sidebar because I don't need it anymore. But I've got the file path on my clipboard. I'll select the one that's in here and then Control-V to put the one for my new file in its place. This cell here is creating two values, in file and out file. In file is the file I want it to work on, and then out file is going to be the name of the file that pixel sort hopefully produces. Let's try it, see what happens. If that worked, that should put a new file in my file manager, and there it is. And I can take a look at it by double clicking on it here, and let's see what happens. Now I've got my window zoomed in quite a lot, so it's kind of hard to see, but if I move it over, yeah, okay, that looks pretty good. That is definitely a pixel sorted cloud. That pixel sorted cloud looked okay, and the fact that it exists proved that the pixel sort process works, but there are a lot of different options that I can play with to create different effects, and I'm going to try that here. I'm calling this step iterate because it's something that you can do over and over again until you get something you really like. I need to change my in file to the correct path, so I'll put that back to cloud smaller, and demo, I'll keep it on demo just because I want to keep changing it and seeing what happens. Down here, this is where the magic happens on line 5, and you can see this line is different than it was in the demo. In the demo step up here, it just processed the image with the default settings, but now I've changed quite a few of the settings. There are lots and lots of settings, and those are pretty well described on the GitHub page. The only issue on the GitHub page is that these are described with the flag that corresponds to the different parameters, and flags only work if you're using this on a command line. I'm not using this on a command line here, I'm using this as a Python module. So I had to go into the source code and figure this out, but these are the argument names that you can actually apply to use these functions if you're running this as a module like I am here. So in this example, I've set the angle to a number, 270, that's an integer, and I've set the upper threshold to 1? I don't want to do that. Let me make that 0.7, and I'm going to sort by, let's say, instead of hue, let's say lightness. Notice that for the sorting function, this needs to be a string, so I put it in quotes. The options for these are available down here. I just put this into this notebook here. So if I set the sorting function, these are the options I can set the sorting function to: lightness, hue, saturation, intensity, and minimum. So I'm going to try lightness with the angle of 270 and the upper threshold of 0.7. And let's see what this looks like. Actually, I will name this demo_1 just to make sure that I can compare the results. Let's see how this looks. Okay. Again, it's kind of hard to see because of how zoomed in I am, but that's looking all right. I kind of was hoping for more like a dripping cloud effect, so let me try a couple other things. Let's change, instead of the sorting function on lightness, let's try hue, which is like what color it is. I kind of feel like most of this image has the same hue, so I don't know if this will actually do much. Let's see. Whoa. That certainly did something. If I can, I'd like to see it. There it is. Yeah, that looks cool. I really like that middle part there. It definitely looks like it's being pulled down out of the sky. Yeah, this is good. I'm happy with that. But let's see what else we can do. Let's make a lower threshold. Let's see if we can just sort just a small amount of this. So we'll say lower threshold, and this also needs to be a decimal number between 0 and 1. So let's say 0.5 for the lower threshold, and let's say 1 for the upper threshold. Honestly, no idea what this is going to look like, or very little idea, I should say. So let's take a look there. And oh yeah, okay, great. So it looks like it really only applied to the middle part, which is what I was suspecting. So the outer part, the sky, stayed pretty much the same because it's all pretty much the same hue, but the hue changes a lot within the cloud, and that's what got sorted. So yeah, very nice. I really recommend just trying the different functions and seeing what happens. Just make sure you keep track of the out file name. This should always be unique, or else it'll overwrite the previous one you generated. I thought I'd also demonstrate a slightly more complicated example that uses a second image as a mask for the image that I want to pixel sort. And in this code cell, you can see it here. This is the cloud smaller JPEG image that I'm working on. And then this is the mask file. Both of these have to be read in with the image module, which happens here on lines 6 and 7. And then the mask value is passed into the pixel sort module right here. So mask image is the name of the parameter and mask is the value. It has to be the fully loaded image from the image module for it to work. So let's take a look at the mask. This is what the mask image looks like. It's a black background with a white circle in the middle. Masks have to be all black and white for this to work. And what this is doing is creating a cookie cutter. So the only part that's going to get sorted in this example is the white part in the middle there. Let's see what it looks like. I'm just running it here, and notice that it's going to save as demo_2.png. Let's take a look at what that looks like. And yeah, as you can see, it kind of creates almost a spherical effect right in the middle, and it's that pulling down thing again, but it's just that middle part. So this is a pretty simple example of a mask, but you could imagine probably much more complicated masks that could create pretty interesting effects, or patterns, or shapes. And that's pretty much it. Again, I recommend just trying different things and seeing what happens. Just remember, if you're working in a Colab Notebook, the files that are created here don't last forever, so if you like them, you should download them. And if you want people to see them, you should share them, put them on an imagery gallery, share them on Twitter, whatever you'd like to do. So that is pixel sorting. I hope the tutorial was helpful. I hope it made sense. If you have any questions, let me know in the comments. And if you make something cool, let me know in the comments as well. Share what you make. I'd love to see it. Thanks for watching. Bye.